All right, we're now working on 3-3, proving lines parallel, page 167 through 33 on and 47 and 48. And we're going to look at some of these problems. In order to prove lines parallel, you have to prove that the alternate interior angles are congruent, corresponding angles are congruent, and same-sided angles are supplementary. And there's a couple other ways, but these three are the best and the most common method of proving lines parallel. Let's look at number 9. Which lines or segments are in parallel justify? We know that line CM and HA has to be parallel because these two corresponding angles are congruent. So if you have two corresponding angles that are congruent, then the lines are parallel. Okay, let's move to number 13. Find the value of x, which these two are parallel. That means this angle and this angle has to be congruent because they're corresponding angles. So we're going to write x equals 25 equals 55, x equals 30, and we'll put 30 back into here, so this becomes 30 plus 25. This also becomes 50 degrees. Okay, and for this one, these two are alternate interior angles, and one of these two has to be congruent. So that means 95 has to also equal 2x minus 5. 100 equals 2x, x equals 50 for those two lines to be parallel. Okay, moving along, number 27, find the values of x for which L and M are parallel. So if we want this to be parallel, that means this angle and this angle has to be congruent, or alternate interior angle, right? So if this is 17x, then this has to be 17x. And we can write, we know that 19x plus 17x are supplementary. It's going to be 30. 6x equals 180, x equals 5. All right, and look at number 28. Same way, if we know if we want these two to be parallel, then means we need to prove that this angle and this angle are supplementary, and we know that these two are vertical angles. So 5x plus 40, which is right here as well, plus 2x has to equal 180, and we've got 7x equals 140, x equals 20. Moving on. Okay, this time we're going to do, we have another problem. We're going to do a proof, a two-column proof, to prove that angle L is parallel to angle M. We're going to have our statements, reasons. We have a two-column proof like so. Number 1, we always write down the measure of angle 3 plus measure of angle 6. This is a given statement. Always write down the given first. That means angle 3 and angle 6 is equal to 180. Okay. Okay, then measure of angle 6 plus measure of angle 7 is also equal to 180. This is a supplementary angles. All right. Okay, to continue, then we know that angle 6 congruent to angle 6, so we can say measure of angle 3 plus measure of angle 6 is congruent to measure of angle 6 plus angle 7, measure of angle 7. Why? Substitution. We substituted these two together, and then we can say measure of angle 7 is congruent to measure of angle 3, subtraction, and then we know that L has to be parallel to M. This is the converse of the corresponding angle theorem. Okay. And lastly, let's look at one more problem here. Measure of angle 1, it's right there. Measure of angle 2. Determine the value of x for which R has to be parallel to S. So these are corresponding angles, so we have to make them equal each other. Subtract 80 here. Subtract, I think you get 10. You're going to add 2x. Add 2x. You have x equals 10. When x equals 10, R is parallel to S because they're corresponding angles and they have to be congruent.